Hello, welcome back. Today we'll do another question on finding in-order successor in the BST. This question is equivalent to LeetCode 510. That LeetCode question is a LeetCode premium question, but you can do it for free in LeetCode. I left the link to the LeetCode question in the description below. We are given a node in a binary search tree. Our job is to return the in-order successor of this node in the binary search tree. Here's the functional definition. So we give it a node and we return the node of the in-order successor. Now looking at the class of the tree node, it has the value of the nodes, pointer to the left child and the right child, and also has a pointer to the parents of this node. First, let's talk about BSTs. So this is a simple BST. You have the root nodes on top, and you have a left child and a right child. The left child has a smaller value than the root node, and the right child has a bigger value. So what is an in-order successor? If we are looking for the in-order successor of 1, that will be 2. If we are looking for the in-order successor of 2, that will be 3 in this tree. And if we are looking for the in-order successor of 3, there is none in this tree. Let's take a look at this more complicated tree. If we are tasked to find the in-order successor of 15, that will be 17. And if we want to find the in-order successor of 13, we'll walk up the tree and find 15. That is the in-order successor of 13. Given the previous two examples, we know the in-order successor of a node can either be in the nodes below the current node or above the current node. So when do we go up the tree and when do we go down the tree? Basically, there are only two scenarios. When the nodes that we are given, if that node has a right child, so in this case, the node 7, it does have a right child, then we know the in-order successor 7 must be in a subtree below 7. In fact, it's on the right subtree below 7, so we have to search downwards, find 9. In fact, when we search the in-order successor in the right subtree, we are looking for the leftmost node. If the node has no right child, then we have to search the in-order successor outwards. For example, in this case, if we are given the node 13, to find the in-order successor of 13, we have to go upwards to find 15. Let's start with the scenario on the left-hand side. Let's build up the pseudocode. Here's our function that we have to write. If there is a right child for that node, then we have to find the leftmost node of that right child. What is this function, find leftmost node? Well, we have to keep going left. So if there is no left, so for example, in this case, if there is no the 9th node, then we just return 13. So if there's no left, then return the node itself. Otherwise, we will just go left using the same function, find leftmost node of left child. Okay, let's talk about scenario number 2 on the right-hand side. If the node that we are given has no right child, then we have to search above. We have to look for the parents. So which parents are we looking for? We're looking for the parents of a bigger value. For example, here we're given node 13. We have to look for the nodes that has a larger value than 13, which in this case is 15. So let's pseudocode this part of the logic. This part we already talked about. That's the scenario on the right. The next part, let's just make a function. If there's no right child, then we just call this find parents function. What is this find parents function? And when will we know when we find the right parents? Well, you will keep going up. You always check whether the parents' value is higher than the current value. If the parents' value is greater than the node value, then we just return the parents. So for example, if you are at 6, you check the parents is 15, and that has a higher value than 6, then you return node 15. Otherwise, you will recurse using the same find parent function on the parents node. For example, if you're at 7 and you check the parents 6, 6 is less than 7, so you will call the find parents function on 6. And that's all the codes you need to cover the scenario. Now, putting everything together, this is what we have. We have the scenario where the right node is present. Find the leftmost nodes using this function. If there is no right nodes, then we just call another function called findParents. And the findParents function will check whether the parent node has a higher value than the current one. Now we convert this pseudocode to Java. This Java implementation is available in the GitHub links below. We'll put all the base cases here. If null equals null, return null. The other part of the function is the same as in the pseudocode. Before we test the code, let's talk about the time complexity. The time complexity should be big O of height of the tree. If we are given a pathological tree where one side is unbalanced, then the runtime can be as much as big O of n. If we have a balanced tree, then the runtime is big O of log n. Now let's test if this works. And it looks good. I hope you like these two videos on finding Inorder Successor of a node in a binary search tree. If you want to support this channel, please like, subscribe, leave a comment. I will see you next time.